Thanks, Seth, for bringing me to this exciting opportunity to talk to NY NLP community. So I will be talking about how and why to build a distributed search engine. So here's our project website. You can find a lot of information about the project there, including white paper, a link to our current code base, my own information through which you can contact me. So here's the outline of my talk today. So I will start with a motivation and vision how to build such a search engine. And then I will cover what are the challenges and how we are going to address them. Then I will talk about the architecture, and the last maybe 20 to 15 minutes, I will talk about natural language processing tasks that are associated to this problem. So I want to start with covering brief how information is processed by humans in the context of human-computer interaction. So each person has personal data streams through which that person accumulates the information. Mostly these data streams are in terms of texts that that person reads. It could be books, it could be websites, newspapers, and there is a lot of information that is generated in the course of this information consumption. For example, eye moves are very important because they show how attention is distributed for that material that the person is consuming. And this information can be used to get an insight of what's actually going on from information theory point of view in the person's mind. And there is a lot of academic research that goes in this direction. So now all of this information is not available, it's basically wasted. And the reason for this is that there are no tools to meaningfully accumulate this information and make use out of that. And likewise, there are information streams associated to large organizations, in particular developer communities. In this case, individuals are interacting with code bases in particular way, and there is wealth of information in terms of the attention patterns again. And so one of the goals in the long run is to create an information system that would utilize and synthesize this information so that people can make use out of this information. And this aligns with the goal of transforming the web into a knowledge system rather than a repository of data. There are multiple technological revolutions ongoing at the moment. In particular, there is a revolution that is about using neural networks for data processing. Another revolution is about using quantum for compute. I'm fortunate to work on both of these in both of these directions. And yet another revolution has to do with using public ledgers as systems of trust. And hyperledgers are ideally suitable for bookkeeping in a large businesses. So there's an ongoing movement of decentralizing various businesses by providing a hyperledger backend. And one of the businesses is the internet search business. So I will explain in this talk how we can leverage hyperledger technology in order to back search business by a system of ledgers and blockchains to make it trustless and to make it transparent and profitable for the participants. So let me, as you know, there are transformative changes happening in the web search business now. But nonetheless, let me try to summarize how search looks like nowadays. So search is a very competitive business, and it's very centralized. In fact, about 93% of search queries go to Google, at least English queries. So these companies that provide search services make a lot of money based off user data. And users are basically products. They get nothing, although they produce most of this data. Production code is closed source. And although there is some change, but still most of the production code is not available for public use, with certain exceptions, which I will cover below. If you're talking about language models, then some very interesting benchmarks became available to us that you can actually experiment with them yourself on GitHub. We see also wide community participation. So, for example, Hugging Face model, these have very many models in that contributed by the community. And last but not least, excellent new data sets were created, and they are still being created. And people are working actively on creating new data sets. And we are working actively on creating new data sets, as I will talk below. Yeah, so here's a screenshot of Hugging Face models list here, and you see that there are literally thousands of different models. So if you are talking about decentralizing search, then we got to keep what kind of community stands behind search these days. So first and foremost, these are AI teams in Google, Microsoft, and other companies. And there are quite a few new startups that emerged recently that utilize new technologies. I am just briefly mentioning some of them. There are very many others. So if we think about decentralizing search business, is about first and foremost is about creating a computational interface that would allow team members to earn better salary by participating in the system rather than working for these companies, because that's what drives them. So let me cover briefly what is the current revenue model behind search. So almost 100% of Google revenue is in the form of advertisement. So they have a very robust and ramified delivery system. And the pricing of advertisements is organized as a bidding system. In other words, there is a bidding mechanism that drives price formation. And if you look at this pricing, and if you look in detail on what actually, how to program such a system, you will see that actually it's possible to back it up by a ledger system, by a smart contract system. For example, this bidding system is literally an exercise in modern blockchain programming languages like Solidity. So this part can be put on the blockchain and made transparent. Of course, there are some problems with scalability because the number of advertisement delivery transactions is very large. So we have to build a scalable solution to drive this. And indeed, we came up with an architecture that would allow us to scale this. But now let's look at what is the technological challenge of building such a search system. First of all, according to some estimates, the amount of data on the web is on the order of 10 petabytes, according to some estimates. But note that if we clean this data and extract only text and only English text, then it's actually quite substantially less. It's actually around 1 terabytes, and I will cover in more detail where is this number coming from. Then, in order to build a decentralized search, we have to accumulate massive CPU usage and bandwidth. We also have to think about distributed GPU compute. And then, very importantly, we have to respect the user's expectations. We don't have more than half a second to deliver query results, at least search results. And then, since we are building decentralized system, we have to care about various attacks that people can launch against the system, such as rank manipulation. For example, somebody can try to ramp up rank of some particular page or server, and we have to come up with a mechanism to prevent this. So we have to prevent collusion between nodes that are delivering rank results. And apart from that, there is no known issue of advertisement fraud when attackers try to cheat the system in terms of simulating clicks. And even on the network level, there could be actors that try to mess up network traffic in various ways. And recently, there are different sort of challenges that are coming up as artificial intelligence systems become very proficient in generating human-like text. So it's quite conceivable that very soon we will see many pages that were generated by computer, and we have to be able to deal with them, at least to classify them as such. And I must say that the commercial classification and the AI recognition systems are quite good. they detect the text that generated by other systems quite well with very high accuracy. And that's what we will have to imitate. But this is, the central challenge, of course, is about building high quality search experience for users. So this has to be a community effort because and the way we think about it is we think about it as Linux, as how Linux community operates, or maybe IETF, Internet Engineering Task Force, operates. So we think about it as creating infrastructure in which individual maintainers, individual enthusiasts can contribute to the system to make it more robust and improve search quality. So what are the issues that need to be addressed? So first of all, search, at least the traditional search, is mostly about information retrieval. It's about finding the pages on this on the web that contain particular words. But now search is changing, so at least part of the search has to do with summarization of long documents and generation of explanations and stories. So, but the first benchmark that we have to compare ourselves against is a good coverage of the web, a good crawler. And we have to create a suite to maintain constantly evolving language models. So we would allow to compute over data capabilities. And then we have to create incentive model for the community to participate. And very importantly, as recent experiments by OpenAI, for example, show that user data have to be used in a meaningful way to improve the inner workings of the models. So we have to come up with ways to accumulate the user data in terms of reinforcement learning and feedback to the model. So in other words, when we talk about distributed computing system here, we have to allocate some space on this distributed cluster of computers where we'll be storing human data, and it has to be encrypted. It has to be anonymized and encrypted and available for researchers to do compute over it. But before I go into the algorithmic details, let me briefly show you how hardware side looks. So here's, for example, how 3 petabyte solid-state drive looks like. So actually, the question one of the questions that probably come to your mind is, where are we getting the compute power to do this massive parallel job, massive parallel compute job? Well, let me briefly tell you what's going on in the area of cryptocurrency mining. So a few years ago, individual miners could still operate their mining rigs for profit. Now I'm not sure if it's possible, but those mining rigs were quite professionally built pieces of hardware. They cost a lot of money. I actually really admire those people who maintain this sort of mining rigs. Nowadays, the situation changes, and a lot of crypto mining is done in data centers, for example, like this one. And by the way, many of these machines are rented to individual customers. So the company maintains this wonderful mining center, but actually individual users are paying for these machines. Here's another one, a Genesis mining. So it is known that Bitcoin energy consumption is actually exceeds energy consumption by some countries, as this chart shows. So this gives me hope that there is compute available in the world to maintain distributed search operation. What we have to do is we have to build a system that allows people who are operating these machines to operate them for other purposes, for knowledge mining. So here's the vision, how we think about our so the network would be similar to Ethereum network. The search will be performed by a system of trustless nodes. There will be multiple roles, and such roles include crawling the web, data storage, ranking, and query accumulation. All of these roles have to do, these further roles here have to do with how queries are being served. Now, since it has to be trustless, we have to prevent collusion between nodes, and we for this purpose we will have this randomness servers, and what this means I will explain in a moment. So in this system, each search transaction would be recorded on a blockchain, on a distributed ledger. And once the transaction is recorded, some fraction of the advertisement revenue would be distributed to the participating nodes according to the contract. So we will have a blockchain, a contract with which participating nodes register, and once the transaction is complete, that there is a signal sent by the browser of the user that will trigger the distribution of the revenue to the participants. If scaled properly, part of this compute can be done even from a laptop. So the way we think about it is that each transaction is run by multiple machines, so they can cross-check each other. So we don't. What I want to say here is that we don't rely on the reliability of. We don't assume reliability of nodes. They can go offline or they can misbehave in an arbitrary way. We'll be cross-checking them constantly. So here are some details on the architecture. First of all, we split the URL namespace into chunks and distribute those chunks according to disk size of the registered nodes. So that the namespace is covered by machines, and for each interval in namespace, there are multiple machines that serve that namespace. Now, here is where randomness servers come into play. We don't want machines from the same user to cover the same namespace, the same interval in the namespace, because otherwise they can collude and manipulate the rank. But if you have a source of good randomness, we can distribute them differently and prevent them. So we would need some manager nodes to do assignment of data roles, but even the manager roles can be decentralized. So basically, we envision splitting the whole population of nodes in two subpopulations. One population is doing the crawl and data service roles, and then there is another subnetwork that collects the statistics and does the job distribution in the worker network. And for this manager subnetwork maintains its own blockchain where they record the cluster state, the distributed cluster state, and the operations. So there is there are actually multiple distributed ledgers behind each of these operations. So we think about this compute system as being decentralized, but still it is meaningful to create a seed cluster. And that's what I will be talking next. So here are some cost analysis here, but I probably skip this due to the lack of time. What I just want to say is that with about 100 good machines, we can run a prototype of such a system. And actually, that's what we did. I will show you the results of our experiments later on. So, very important problem is to maintain latency under control here. And for this purpose, the index have to be organized into a tree structure, with D being multiplicity of this tree. Then the height of this tree is logarithmic in the number of pages that we want to serve. So here's here are further details on our latency analysis here. So here's the formula for the total latency of such an index. And the result of this analysis for a retail-based network with 30 megabyte per second speed, we get to about 0.3 seconds to process the transaction locally. This is our latency budget. And we here assume that each node is actually minimal. Each node is assigned to about 10 gigabytes of data. So they don't even store much data. Now, we analyzed various attacks on it, but I probably should skip this and go to the actual NLP part, because that's probably what you want, what you're most interested in. Yeah, I have a lot of details about the financial system and about the tokenomics. So what we have already done. So we built a distributed crawler, indexator, return tree for query merge, an iterative rank computation for page rank. So I built the corresponding protocols, message verification, and we build the code stack for manager nodes, and we maintain the search blockchain. let me show you the results of our recent crawl. So we are running a cluster of 100 C6 large nodes from AWS, and that's the CPU utilization. You see it flattens out to 40%, which is actually not ideal. And we don't see this behavior on smaller clusters. For example, when we run it on clusters of 10 nodes, we see near 90% CPU utilization. And why is it happening? Well, I suspect that it's because well, most of the data come from large servers, and they probably become aware that somebody is scrolling them. Also, we take a lot of caution not to overburden the servers. So, you know, crawling is actually a tricky business. We have to care about not overburdening some particular servers. So we have to distribute the crawl requests such that they go to different servers. But still, probably 100 nodes is too much, and the requests build up noticeably. So here are some details on the performance here. With hundreds of these machines, we were crawling at about 3,000 pages per second on average. As the benchmark, there are about 50 billion pages on the web. That's the estimate. So we crawled during this time. We crawled something like 6 terabytes of data, but this is not clean data. This is raw HTML. So what we are working on is a pluggable ranking function, because now we only have page ranking there, which is not enough, of course. And then we are building the corresponding financial system. Well, we have a prototype code which we wrote on Ethereum blockchain, and our crypto token is called Knowledge Coin, for obvious reasons. Now, concerning the use of the NLP problems that we are working on right now as well, is the use of transformers and other sequence models for search. So first of all, I should say that use of transformers for search is widely open problem. And this is witnessed by the large number of works from Google and Microsoft teams. If you look at how they experiment with query rephrasal and explorative search, there are literally dozens of high quality works in there. Now, query correction, on the other hand, is mostly solved problem, and people solve it using well-established BERT technology. For search, it is very important to pre-rank pages, because if you search for some rare words, this is actually not a problem if you have like a dozen of sites, a dozen of pages that contain that word, and you can return all of them. But that's not very typical situation, I should say. And on many occasions, people query for some common words, or they issue long queries. And to serve this sort of queries, we have to pre-rank the pages, which we will then summarize and rank based on queries. So one of the problems is, how do we use transformer models to pre-rank pages based on the amount of information that they contain. And the actual rank that the user will see has to be related to the maximal information contained in the page relative to, first of all, query, and then the history of the user, where QI here are individual queries that the user issued, and B are actually behaviors that user exhibited, if the user allows us to see those behaviors. And by behaviors, I mean click information and scroll information. So there is a number of works that recently became available. First of all, there is WebGPT paper. Then there are some paper from OpenAI. Unfortunately, the code base behind each of these papers is not released, so you can only guess what's going on there. But what we know for sure is that there is a GPU cluster behind each of those chat interfaces, which makes things difficult for us because graphic processing units are expensive. And so far, we were able to utilize only CPUs from the community of users that joined our project. So here are some tasks on which GPTs were trained. And you see, let's see, yeah, right. So none of these tasks is actually directly related to search. For example, the GPT structure is not aware of hyperlink or DOM, document object model. It's also unaware of individual history and click data. Now there are some conceptual or potential problems with the transformer models. For example, it doesn't respect the higher order logic structure and the word hierarchy. Of course, you might argue that it's not even necessary because those words are somehow disintegrated into weights of the system. And that might be true, but nonetheless, it's subjectively true that there is a hierarchy of concepts, and probably some further experimentation would be necessary to settle this problem. And it's hard to have transformers work with longer contexts, as you know that the complexity of the operation is quadratic in the context size, and there's a lot of work going into generalization of attention for longer sequences, all sorts of sparse attentions. And importantly, transformers have problems with deep computations. For example, they are good at plus computations, but they are performing worse on same multiplication. So if you think about deeper recursions, then you would expect even poorer performance. And that, of course, has to do with modeling higher order logic structures, because because those are precisely about deeper recursions. So in our context, we don't really think about training GPTs in distributed way, because the training of GPTs relies on high data rates. So there are excellent programming suites for distributed training, but not that this are all done in cluster. So you won't be able to generalize this over the internet. And what we can do is we can use the pre-trained model. and serve the computation from distributed network. And there is already some work that is done by this, for example, these two startups. And we are working on our own implementation. Yeah, as I said, the distributed training can only be done on clusters, and we are thinking about. So the way we think about this is that we will train the model on the cluster and then use it to serve from a distributed network. So here are some of our next steps. First of all, we will optimize. We need to optimize our current code. Run the code to do full web crawl and create our own dynamic data set. As you know, that most of the data sets, at least the large ones on which the largest models are trained, are descendants of common crawl. And common crawl, well, it has problems. For example, within single crawl, they actually crawl the page several times. So there is this redundancy. We actually get rid of this in our crawler. And then if you want to do search, then this data set has to be dynamic. And the next step is to run a seed cluster. And this is problematic for us because we are just distributed community of academicians. We don't really have funds for this for running a large cluster based on our resources. So we are building a system, actually open system, in which people can gradually join. So this is about it, and I think I should stop here and address questions if there are any.
Stan, we had one question in the Q&A. Why are advertisements necessary in a distributed search application?
Why? Well, it's because otherwise people will not have incentive to actually run the nodes. Excuse me. Sorry.
Yeah, that makes sense. Advertisement, someone has to pay for this. You have a question from Vitaly in the chat. Is there still enough information in HTML not hidden with JavaScript to crawl? Stan? Huh. We seem to have lost our, I'm going to go on video.
Oh,
you're
hello.
back. Yes. We lost you for a moment there. Stan, you have a question that was in the chat from Vitaly. Is there still enough information in HTML not hidden with JavaScript to crawl?
Yeah, so that's an excellent question. And indeed, there emerged many sites for which we need headless execution to actually see the text. And that's one other thing that we will have to address. Some of us actually working on that.
All right, do we have other questions? You can use the Q&A for your question, or if you want to ask your question live, use the Zoom raise hand feature, and I will enable you to ask your question live. Any takers? Okay, well, I'm not seeing any takers here. I guess we'll wrap up in that case. Stan, do you want to share your contact information or anything like that?
Yeah, you can. Just give me a second. So, You can go to this website and you will see contact information of some of us in there.
Okay.
Yep.
We had another question in the chat from Vitaly. How do you compete with Google? I'm not sure you do, but anyway, how do you compete with Google? The question's for you, not me.
Well, we are building decentralized network of researchers who will be on the infrastructure. And actually, this is an open question, of course, right? So it's it's actually a project in decentralizing search business, and actually, this is for us. It's a research question if we can build a decentralized community that would compete with Google, right? Or if we can show more profitable model for people from Google community to join this framework. So it's about setting up a way to accumulate both compute and human resources in order to drive search code for the new generation. I think it's not totally well. We have in front of us examples of Linux Foundation and IETF, which are decentralized communities, and that's what we want. This is the kind of model that we want to use.
You know, I suppose the answer is similar to how do you compete with Elon Musk and Twitter after his takeover for Twitter? And one of the answers is Mastodon, which is decentralized and distributed with decentralized servers and all of that. So, you know, that's an analogous architectural answer. You have another question in the Q&A from Adil. Can you use depth-first search or breadth-first search using reinforcement learning method for a crawler? If you want to read it yourself, it's in the Q&A, you should be able to see it.
All right, yeah. Well, I'm not sure if I fully understand this question. For actually serving the queries, there is no reinforcement learning at that point. The reinforcement learning comes at the step when we train our model, and we adjust those parameters that are used to compute the pre-rank. But once the query comes in on a given model, it's just about delivering highest ranking pages. So the use of reinforcement learning based on user data is on the stage where we prepare those the model for service.
Adil, do you want to elaborate on your question? Or, you know, again, if anyone wants to ask a question live, if you use raise hand, I can enable you. Adil asks, not on link crawl analysis. In other words, what people, I suppose that means what people click on in response. In the
yeah, right. Oh, yeah, that's a good question. Right. So the question, okay, so the issue here is, first of all, how do we incentivize people to reveal this information? Because nobody, how do we anonymize it? So we certainly work on the solutions for this, but there is immediate problem how we enable storage of this click information and on distributed ledger. How do we make it available for researchers to experiment with it? Yeah, but this is a work in progress. There are a lot of technical issues there. If you want to join our effort, you're welcome to explore the data on our website and contact us. There's plenty of things to do there. We are just a small group of NLP enthusiasts, and there are more problems than this that we can have hands for.
Do we have other questions for Stan? Check the chat, not anything there. All right, last call, any takers, any questions for Stan? right, I guess not. So, I'll thank you for your presentation, Stan. And as I have mentioned, the video will be available later today, I think, on YouTube, on our channel. I'm going to reshare that information, except I seem to have closed it. So let me quickly reopen it. And here we are. Where are we? Give me a second. Right. I will share the video once it's done processing on the YouTube channel. That's the NLPXING. You can go to that bit.ly address. It's the easiest way to get to the YouTube channel. And then I will repeat that we have a couple of programs in the pipeline for next month, for March, on March 15th and March 28th. Those are not posted yet, except to the New York NLP meetup page, because I'm waiting for a complete abstract and bio from Hasham al-Haq from John Snow Labs. But to save the date for those two programs, they'll be at the same time of day, 2 p.m. US Eastern, 8 p.m. Central European Time, 11 a.m. US Pacific, on the days that are indicated. So once again, thanks very much, Stan, for presenting, and see you all next time, next month, I hope.
Thank you.